Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in this special English language video, we will discuss one very popular joint engineering examination question pattern from electromagnetism, and we will learn superposition of magnetic field flux densities using vector summation techniques. This question pattern will involve both capabilities of mathematical manipulation and clarity of all sort of concepts. So let's understand this popular JEE physics examination pattern. We have given two straight parallel infinite conductor placed perpendicular to xy plane at coordinate 0a and 0 minus a. They carry current in opposite direction as shown here, and the mutual distance between two conductors will become a from origin in one side and a from origin in another side, so total become 2a. Now we have to find out resultant magnetic field flux density contribution by these two conductor at this coordinate on x-axis at 2a distance from origin, that means at 2a 0. As for vector representation of Biot Savart Law, magnetic field contribution of current length at any observation position represented by directional vector r is perpendicular to the plane which contain current length and distance vector. Assume a vertical plane to xy plane, and this direction in z direction represent outward current of conductor A represented by dot here, and this is position vector of observation point from current vector, and this plane contain both current length and position vector, and our magnetic field should be perpendicular to this plane either in this direction or in that direction. That can be obtained by Maxwell right hand rule. Similarly, this another vertical plane to xy plane contain downward current of B conductor and position vector of same observation point from conductor B, and our magnetic field contribution of this B conductor current is either perpendicular to this plane in this direction or in opposite direction. That can be checked by Maxwell right hand rule. So magnetic field of this current at this observation position is perpendicular to this plane which contain current length and position vector, and the direction is given by Maxwell right hand rule. This conductor is gripped in right hand with thumb pointing the direction of current, and this curl of finger represent concentric circle format of magnetic field around this conductor. To find out direction of magnetic field at a specific position, we have to brought the tip of finger at that position. So when we rotate hand such that thumb is maintained in the direction of current and tip of finger comes at observation position, and this tangential direction BA represent magnetic field flux density of conductor positioned at A point. Similarly, for this conductor of position B carrying current in downward direction, the magnetic field at this observation position is perpendicular to this plane containing current length shown by this red arrow and position vector shown by blue arrow. As per Maxwell right hand thumb rule, conductor is gripped in right hand and the straight current is represented by straight position of thumb inward. Then the curl of finger around this conductor represent concentric circle of magnetic field, and to find out magnetic field at this position, this tip is brought here and tip indicate this direction of magnetic field from conductor placed at B position. So this A conductor produce its magnetic field in this direction and B conductor produce magnetic field in this direction. So conductor of position A at 0a coordinate has produced this magnetic field at observation point of coordinate 2a 0, and similarly conductor placed at B position of 0 minus a coordinates has produced this magnetic field at the same observation position. As per superposition principle, the total magnetic field contribution is sum of individual field contributions, but since magnetic field flux density is a vector quantity, so we have to make vector summation, and for vector simplification we can do a little manipulation and we can resolve these two components, one along x-axis, and x-axis component of A position conductor is BAX and B position conductor is BBX. Similarly, the same magnetic field is resolved perpendicular to this x-axis, that is along y-axis. Y component of magnetic field produced by A position conductor current is BAY. Similarly, B position conductor current is producing y component B by. Now due to symmetry of this configuration, these two y component are equal and opposite, so they get cancel out, and to get these axial component from this, let angle between x-axis and magnetic field flux density contribution is theta. Now this magnetic field is perpendicular to this position vector, and this x-axis is perpendicular to this line joining two conductor y-axis. Then this theta and that theta is same, so axial component is cos theta component, and the two magnetic field contribution by the symmetry of this configuration are identical in magnitude. So one component is b cos theta, and two components same magnitude same direction become 2b cos theta. Now magnetic field at this position from an infinite long conductor having perpendicular distance of this much, and this perpendicular distance is obtained by Pythagoras calculation in this upper triangle with base a and perpendicular to a. The Pythagoras calculation says that hypotenuse is root 5a, and that become perpendicular minimum distance of this observation position from current length. So infinite length carrying I current produce magnetic field at r perpendicular distance equal to this much amount, where r is root 5a, and cos theta in this triangle is based upon hypotenuse, and hypotenuse is r, then it is a by r, and the total magnetic field of axial component summation is twice of one component. Magnetic contribution of current at this position is mu 0 I upon 2 pi root 5a, and cos theta is 1 by root 5, and b cos theta multiplied by 2 will become mu 0 I a upon 5 pi a square. 1a will get cancel out from numerator denominator, and the final answer will become mu 0 I upon 5 pi a in x direction. Now the same question can be modified with the change of directions of current in these two parallel conductor. Now these currents are in opposite direction. We could have an example where both current are in the same direction. So when direction of current in this B conductor is revert, and now it become parallel to A position conductor, then resultant magnetic field direction and magnitude both will change. So let's first find out direction, and then we will do magnitude calculation. So for position of state current at A and observation point at this position, the magnetic field must be perpendicular to the plane which contain current as shown in this red arrow in this perpendicular to plane direction and position vector. So this vertical plane contain current element and position vector, and our magnetic field is perpendicular to this plane either in this direction or in opposite direction, and that can be checked by Maxwell right hand rule. As per Maxwell right hand rule, when this conductor is gripped in right hand with thumb pointing the direction of current vertically upward, then curl of finger around it represent concentric circle of magnetic field, and to find out magnetic field at specific position, this tip of curled finger is brought at observation point, and this direction perpendicular to this plane represent magnetic field flux density of conductor placed at A position. Similarly, to find out magnetic field of this vertically upward current placed at B position at this point, we have to consider a plane which contain current element shown by a red arrow and this position vector. So our magnetic field is perpendicular to this vertical plane, and it could be either in this direction or that direction as per Maxwell right hand rule. And when conductor is gripped in right hand with thumb pointing the direction of current, then the tip of this curled finger at observation position indicate this direction of magnetic field from conductor placed at B position. So A position conductor has produced this magnetic induction, and B position conductor has produced magnetic field in this direction. So at this observation position, magnetic field flux density of conductor placed at A position is BA, and at the same position the magnetic field contribution of this conductor placed at B position is given by this vector. And from symmetry of this layout, the axial component of magnetic induction of A conductor and magnetic induction of B conductor are equal and opposite, so they will cancel each other, and the Y component perpendicular to this axis along this line are equal and in the same direction, so they will be simply added up to give total magnetic field induction. And since the two Y component are equal, and if this theta is angle between magnetic induction of one conductor and x-axis, then this Y component is sine theta component, and the two Y component of conductor A and conductor B are equal in magnitude, so resultant magnetic field is 2 times of one Y component. Now magnetic induction of a conductor at this observation position at root 5a perpendicular distance is mu 0 I upon 2 pi r, where r is root 5a, and and its y component is sine theta, and in this triangle sine theta is perpendicular upon hypotenuse, so it become 2 by root 5. If we place root 5a in place of capital R, then it become 2 by root 5, and total magnetic induction is twice of one component. One component is this yellow highlighted part, so just doubling of it will give resultant magnetic field in midway position along y axis, and simplification will make root 5 5, and final result will become 2 times of previous answer in this case, and it is 2 mu 0 I upon 5 pi a, and direction which was earlier in x direction now become in y direction. We have explained one of joint engineering entrance physics examination question pattern to best of our expertise. If you need similar type of solution for a particular question, do suggest that question in your comments, and we will try to satisfy your examination needs. Our other learning video of senior secondary physics playlist are equally useful in your studies, and if you need our online doubt clearing class or dedicated exam centric notes, do join membership of our YouTube channel. Happy learning. Thank you very much.